Hello everyone, welcome back to my lesson. On today's video, we're going to focus on the centripetal force. After we discussed it in a previous lesson about the uniform circular motion and non-uniform circular motion, you have learned that uniform circular motion is a motion of an object that moving in a circular path with a constant speed, which is this object has only centripetal acceleration, not tangential acceleration. Okay, but non-uniform circular motion is a motion of an object that moving in a circular path with a varied speed. Okay, so for today's lesson, we're going to explain centripetal force. What is centripetal force? Centripetal force is a force that acts on an object when it's moving in a circular path, which is directed toward the center. Okay, so it is very important to know that the centripetal force is not directed or it's not acting on an object or it's not acting on the direction of the movement of an object. Okay, so the direction of the centripetal force is always directed toward the center of the circle. Okay, so which is causes the centripetal acceleration. Okay, for example, if you see this bike in this picture, okay, the bike is moving in a circular path. Okay, in the case when the bike is moving at a constant speed, we can say this circular motion is uniform circular motion, which is the tangential speed of this bike is directed tangent of the object, okay, of the circular motion. Okay, at this point the direction of the tangential speed is directed into this direction. Okay, but when the bike reaches at this point, it is tangential speed. Okay, the direction of the tangential speed changes. Okay, so in that case the centripetal force of the bike, okay, is directed toward the center. Okay, what is this? This is Fc, which is causes the centripetal acceleration. Okay, at this point also the direction of the centripetal force is directed toward the center. Okay, so we can say that the direction of the centripetal force is always directed toward the center. Okay, it is not acting with the same, well, acting in the direction of the tangent of the circular path. Okay, so we can calculate the centripetal force by using this equation. Fc, according Newton's second law, is equal to what? MAC. Okay, the mass of the object and the centripetal acceleration that caused by the centripetal force. Okay, as we learned it in a previous lesson. Okay, AC is equal to what? AC is equal to VT square over R. Okay, by using this equation we can finding the value of the centripetal force. Okay, mn is the mass of the object and vt is the tangential speed of the object, and r is the distance is the distance of the circular path or radius of the circular path, distance from the axis of the rotation. Okay, so when an object is rotating, okay, and to find the centripetal force on the rotating body, okay, such as you can see, for example, this is a merry-go, okay, which is rotating or spins around this point. Okay, all points on the rotating body has a centripetal acceleration and centripetal force. For example, if someone standing here, okay, this guy has a centripetal acceleration which is directed toward the center of the spinning. Okay, this merry-go or this cylinder has angular speed. Okay, so we can finding the centripetal force according when the object spins. Okay, by using this equation, as you know, Vt is equal to what? Is equal to omega r. What about Vt square? Is equal to omega square r square. So we can substitute this equation into this equation. Okay, we can finding the centripetal force for an object that's rotating around a fixed axis, which is equal to m. Okay, instead of Vt, write down omega square r square over r. Okay, r with r cancel. Okay, what does remain? Fc is equal to mr omega square. Okay, so we can conclude that what is the difference between these two equations? Okay, the first equations can be used to find the centripetal force when an object is moving in a circular path. For example, if you have a ball and if you tie the ball at the end of the string and moving in a circular path, you can use this equation to find the centripetal force. Also, this equation also can be used to find the centripetal force for an object on a rotating body, okay, which is equal to mr omega squared. For the circular motion, centripetal force is inversely proportional to the radius of the circular path. But for the rotating object, when the object, okay, rotating on the rotating body, you can finding the centripetal force by using this equation, which is equal to mr omega squared. But be careful, this equation, this is not the equation of the centripetal force to finding the centripetal force for the rotating body. The rotating body has no centripetal force and centripetal acceleration. But every point on the rotating body has a centripetal acceleration and centripetal force. For example, as you know, Earth rotating around itself. Okay, so it takes 24 hours for one complete revolution. Okay, so in that case, if you say what is the value of the centripetal force of the rotating Earth around itself, this is wrong. Why? Because the rotating Earth has no centripetal force. But if we say what is the centripetal force on an object on the Earth when it is rotating around an axis or internal axis, yes, we can find the centripetal force by using this equation. Okay, so about the centripetal force, as we know that the centripetal force is a force that acting on the circular motion, which is directed toward the center. Okay, so we have many sources of the centripetal force, or you can say the centripetal force can be provided by various things, such as the gravity. Okay, the source of the centripetal force, gravity. For example, when Earth orbiting around the Sun, orbiting around the Sun in a circular path, so what causes the centripetal force, or what causes to maintain the Earth orbiting around the Sun in a circular path? The answer is the gravitational force between Moon and Earth. Okay, for example, when Earth orbiting around the Sun, the force that keeps the Earth around the Sun is the gravitational force, okay, which is provided by provided by the gravitational force. Okay, the source of the centripetal force between Earth and Sun is the gravitational force. Okay, for example, assume that this is Sun, okay, and Earth is moving or orbiting around the Sun in a circular path. Okay, the force that provided by the gravitational force is the centripetal force. Okay, so you can say Fc is equal to Fg. Another example, the artificial satellite, okay, when it's orbiting around the Earth, also the force that keeps or maintain the artificial satellite to orbiting around the Earth is the gravitational force between the artificial satellite and the Earth, which is called the centripetal force. Okay, so the second source of the centripetal force is the tension force. Okay, what is the second force? Is the tension force, which is the force of the rope when, for example, when a ball is tied at the end of the string and trailed in a circular path. This force of the tension, it goes to maintain the object in a circular path. This force is what? Is a tension force. For example, okay, when the ball, okay, is moving in a circular path, okay, so the force that keeps the object at the circle in this circular path is the tension force. Okay, in the case, for example, when the string is breaks at any point, the object cannot maintain anymore in a circular path. Instead, it's moving or fly off in a straight path. So it means that when the string is breaks, when the object is moving in a circular path, okay, and the strings is breaks, in that case, the ball cannot maintain in a circular path. Instead, it's moving or fly off in a straight path. Okay. Another source of the centripetal force is frictional force. Frictional force. Okay. The frictional force, another source of the centripetal force that keeps an object in a circular path. For example, when a car or when a motorcycle or when a bike is moving in a circular path, okay, in a racetrack, in that case, the force that maintain the object or the car to moving in a circular path is the static frictional force, okay, which is, for example, if you have road, okay, this is car, okay, the car is moving in a circular path, okay, this is centripetal force, which is provided by what? By the static force, okay, or by a friction. What do you mean by Fs? The static frictional force can be it's very important to maintain an object in a circular path, okay. The centripetal force that provided by the static frictional force for an object or for a car when it's moving in a circular path. So in that case, Fc is equal to Fs. For the tension force, Ft is equal to Fc. For the gravity, Fg is equal to Fc. Okay, so that's all for today. Hope you benefited my lesson, and don't forget to subscribe my YouTube channel. Okay, thank you.